So we are good to go. Think we're live now. Take it away, Amir.
For a self-driving car to make sure that hey, this is a stop sign, or this is a pedestrian. You probably don't want to hit that person, or understanding different stop signs and street signs and so on. So my experience has been pretty varied in a lot of different industries, from robotics, augmented reality, consumer cameras, self-driving cars, medical, and currently in augmented reality. So it's been pretty much all over the board, but the core focus is computer vision, machine learning, and deep learning for building cool stuff.
Great. So that's a lot of related stuff that we want to talk about today. So before I jump into questions, I just wanted a little bit of help from our audience. My neighbor's having a little bit of construction, so let me know if so. So sometimes when I mute from my end, we have a little bit of challenge on the voice. So I'm just going to go ahead and mute. And just let me know if you guys can hear my voice, because if I don't go on mute, you're going to hear drill noises and construction noise, basically. So if you could let me know on YouTube chat, if you can still hear the folks talking after I go mute, that would be perfect. And for that period of testing, I just want to ask you again the same question. So what made you decide to go with an office background, Ray?
Oh. Yeah, I've got 100 of different virtual backgrounds to choose from, and it's a running joke at work where at the beginning of each meeting I'll choose a background that I think is suitable to the audience, and I usually go with the office for people that I've not spoken to before, or people that have varied backgrounds, because I guess we can all relate to it. It's a very nerdy show to watch, and we can all kind of relate to it in one way or another. So I figured it was a nice background to kind of bring everybody together.
Sounds good. And then who's the character that you feel most connected to?
Oh, good question.
I can go first if you want.
Yeah, go
Kevin.
First. Kevin, really?
Yeah, I love him.
Is it because of his kind of lackadaisical approach to work and just doing like the bare minimum to get
You got me.
I suppose it's a mixture of let's see here. I would say Andy Bernard and Dwight Schultz. It's a good mix, because I'm definitely an overachiever, but it's not going above and beyond to endanger the lives of people to get it done. So I would say it's a good mix of Andy Bernard and Dwight Schultz, I think.
So it's good that you consider yourself as a salesperson. I like that.
Yeah.
For those who have not watched Office, both of these characters are salespeople.
Yeah.
And it's good that you also mentioned these two names because they always have, they're basically always head to head. I mean,
Yeah, they're
mostly, if not always. So it tells me that you have this thing inside your head that you're always trying to compete with yourself, which is good.
Yeah,
it's a good thing.
It's yeah, definitely. That's a very astute observation.
Thank you. All right, so it was good to have a little bit of fun at the beginning. I think we have quite a lot of people actually watching us live, so I'm really hoping
Cool.
that this would break our records this week. So with that, I should want to jump onto the main questions. And the first question I have for you, Ray.
Sure.
So you've worked as a machine learning engineer. You technically, I mean, can work as a very dominant software engineer even outside the realm of machine learning. You probably can
Sure.
work as a data science product person as well. So
Okay.
that gives us a lot of challenges when asking you questions.
Mhm.
I don't want to have my audience feel like I'm the fool because
No
I don't
worries.
know anything about what you're talking about. So I just go ahead with the easy questions first.
Mhm.
Can you tell us, for our audience members who I would assume, for the most part, they are junior to mid-senior level, um, uh, give us basically your 2 cents on the key differentiators when it comes to machine learning engineering versus the good old, software engineering practice. Um,
Mhm.
and recently, I've seen a lot of folks who are software engineers who are basically just using different machine learning tools, libraries, whatnot.
Yeah, sure.
Do you see any differentiator between somebody who should be called a machine learning engineer based on those differentiators, who's not necessarily just a software engineer user of these frameworks?
Yeah, that's a good question. It's actually one that I get asked all the time. So the lines are being heavily blurred as, especially with proliferation of startups and, just being able to find able-bodied people to get products off the ground. But there's some very subtle differences, I think. When you're trained as a traditional software engineer, you usually have some very clear outline objectives going from A to B, where you have this particular feature you want to develop with, these particular inputs and these particular outputs, and you can actually clearly assess with tests how successful you are. When you as a software engineer that transitions over to kind of an MLE role with using those frameworks, the one thing about machine learning engineering that is a key differentiator is variability. It's very data driven. So you want to be able to build an application that is focused on solving a problem that deals with data. So there's a lot of variability, a lot of moving parts. So one thing that is a constant challenge for software engineers is transitioning from a role where you have clearly defined objectives, clearly defined products that you want to develop, and then when you're going over to a machine learning engineer role, it's like, we want to solve this particular problem. It's not exactly clear how to go from A to B. We have to decide, what the best data to feed, the best model to choose, how to maintain this model after it's deployed. So the variability and constant shift in requirements is one of the biggest challenges for a software engineer that's just trying to transition over to MLE, versus if you were already, trained as a machine learning engineer from the beginning, you are already in this mindset of, yes, there's definitely going to be variability in the products that you develop, as well as pre and post deployment. But the thing is, though, we're learning to adapt. Like, I was not a traditional machine learning engineer when I started. I was actually a software engineer who transitioned over to using ML frameworks and developing kind of data products. So for me, it was definitely a challenge, especially with the variability stuff. Like, it was very weird to develop a functionality where there was let's say you're doing like a coding interview where you're doing a binary tree search or trying to sort things. Like, those are very clearly defined objectives, whereas if a machine learning engineer, well, the things with applications of machine learning is that you're not solving all the corner cases. It's just enough to be able to satisfy requirements for people who are using it. With software engineering, especially with applications and tests, you want to be able to handle all those corner cases. Where as in machine learning, you may not be able to handle all the corner cases, but it should be enough to satisfy the requirements. So you've got that variability and meeting most, or if not all, the requirements. So I say, as we're trying to adapt, I think, as especially with the landscape in terms of what's available in roles and all the companies that are being that are starting off. I think we're learning to better adapt to this kind of variability versus structure, going from point A to point B, instead of it's very data driven. So I think that's the key differentiator. With software engineering, it's more like we have these sets of requirements. We want to build a product based on these requirements, and we have very strict, tests and metrics to be able to meet. Where machine learning has that variability that'll change depending on the kinds of data that you're using, the kinds of people that are using the product, and even post deployment. So I think that those are some of the key differentiators.
I have a follow-up question on that. So it's interesting you mentioned, even within the realm of very predefined, very strict deliverables in software engineering.
Yeah.
I can't remember when, but it's been definitely more than a decade and a half.
Yeah, sure.
Since we basically left the whole waterfall way of doing things and became agile, and now agile is dead, right? So I'm seeing this and I'm hearing what you're saying, and I'm thinking to myself, all right, so every machine learning engineer / data scientist / probably even data engineer should start with agile, whereas in practice, data science and agile, it doesn't make a very nice combo.
Yeah.
Why is that?
That's right.
Why can't we just, and of course we can't go to waterfall when we're working on machine learning engineering, because it will never work. You won't know what's going to happen tomorrow. So how do you go ahead and solve that problem then?
Yeah, that's a good question. It's like, the thing is though, it also depends on the kind of industry you're working with. So let's say you're working in medical devices, for instance. It was always a very traditional kind of waterfall process where you have to do a thorough amount of research, kind of, vet the problem, vet the area, do as much kind of technical deep dive as you can, and then you start actually developing. So with medical devices, it's typically waterfall versus agile, but especially with proliferation of stars, they're trying to transition over to being more agile. But your question is specifically how exactly do we kind of deal with, so let me make sure I understand your question. So you're asking how exactly do we, like, agile is the way to go currently, with software engineering stuff, but it doesn't jive well with, let's say, data science or machine learning practices. So how exactly do we deal with that stuff?
Exactly. And why is that? Why don't they make a nice combo? What's the problem?
Yeah, so I think it's mostly because the products and the requirements, they're always kind of evolving. Like, from when you initially started to develop a particular product, something may have changed, whether or not when you're doing, let's say, some exploratory data analysis or something with the data inputs have changed, where you'll have to shift requirements, or it could be something dealing with, maybe the landscape in terms of the demand. Maybe the demand has changed. So I think the thing with agile is that it can be especially because you're trying to meet objectives, but then they all suddenly change. So I think with that, it can be a little difficult, where with waterfall, you want to be able to get all your ducks in a row before you start implementing, because that will, hopefully, incorporate all of the evolving changes as you're researching. So I think the evolving changes, as well as just, just things change, I think is mostly the kind of the difficulties behind it.
So I actually have a follow-up question related to that. I know you mentioned earlier that a couple of things that you had dealt with, related to like building apps, also pre and post development. There's just like a lot of variability in the industry. So moving from like a software engineering role to a machine learning engineering role, what are some of the skills that you thought carried over really well, and what are some of the things that you thought that you needed to learn but didn't really touch on as much in a software engineering role? And how does that kind of differ in computer vision versus other industries, in your opinion?
Okay, yeah. So one thing that definitely transitioned over very well is when, in terms of developing, be extremely organized, document everything, practice kind of software development lifecycle practices, object-oriented programming, unit tests, like that stuff to be organized, and development transition over very well, because things change a lot, especially when you have, let's say, more headcount that gets added to the product, or if you are, let's say, changing to another project because of resource allocation. So being able to have other people take a look at what you've done to be able to pick up from where you left off is extremely important, especially if you have requirements that are constantly evolving and you have deadlines to meet. So I think being heavily regimented in terms of development practices was something that definitely transitioned over very well. It's especially common in developing computer vision applications versus any kind of data science or machine learning application. I think that definitely is in common. So I think, software development practices definitely transition over well. What I could not get used to, as I mentioned earlier in this talk, was just how variable things are. Like, especially when I was trained in school, where you have these certain objectives that have already been vetted and kind of researched out, and then you have a certain amount of time to get from start to finish. Like it took me a very long time to get used to things constantly changing. Like I'll be working on a particular feature, then all of a sudden I get kicked off to another project, or certain inputs may change and I have to tweak the way that I originally decided to do it. So that was something that was definitely hard to transition over, just the constant variability in developing features and just the project in general.
Yeah, I think for that, I think that's a super, like key point, especially for those. I think we have a lot of people in the audience who are sort of like straddling in between these two kind of like industries, who are trying to move from like one to the other and vice versa. So related to tools now, so something that a lot of people kind of have diverse opinions about are
Sure.
notebooks. So do you use them, and if so, how do you productionize them? And if you do not use them, why not? Like, what are the best practices around these choices that you're making?
And
Yeah, so
if
go
I
ahead,
can extend that question, and you don't have to talk about this, but if you want, I know somebody you used to work with also belongs to one of these schools of thought. He's actually had a lot of strong opinions about. I can't say for or against because it depends on whether or not you want to talk about them. But if you want, you could also talk about them as well.
Sure. So I'm assuming Jupyter Notebooks with Jeremy Howard, I'm assuming, right?
That's
is
right,
who you're-
yes.
Yeah, so it's definitely split down the middle. Like Jeremy Howard is a huge advocate of using Jupyter Notebooks for productionalization, development, like going from end to end. There are opinions that are split about that. Like personally, I think it's good to use them up to a certain point. So I'd say definitely use them if you want to, let's say, share results, if you want to do any collaboration, deciding on what model to use, trying to figure out kind of the nuts and bolts for, let's say, proof of concept or a prototype. It's definitely good to share results and be able to keep stakeholders informed. But when you want to productionize the model, I think that's where it should stop. I think there are other kind of well-equipped frameworks to be able to help you productionalize your model. TensorFlow Extended, Celery, Luigi, Airflow. Like there's a lot of frameworks that I think are already established that can help you pretty much get it to the finish line. But I think notebooks are great for experimentation, sharing results, and just being able to communicate kind of key decisions to stakeholders or other people who are interested. But I think that's where it should stop. There are very kind of well-regimented and dedicated tool sets to be used to actually productionize your model. That's what I personally think. And I think Joel Gru's, I'm not like to the extreme of Joel Gru's where he absolutely hates notebooks.
Yes,
he
does.
He'll open up a terminal and just start typing away and just use an editor. Like I'm kind of a good mix of both, where I'll use it to kind of if I have like a mishmash of thoughts that I just want to put on paper or put on a screen and just being able to experiment and prototype, that's where I'll use it. But I wouldn't go so far as trying to productionize a notebook. What you can do, like worst case, is take the code that you developed in a notebook and put it into some sort of script in the end, and maybe make it command line configurable so that you can call it with other services on the cloud, for instance. But I wouldn't try to take a notebook and productionalize that. It's meant for experimentation and for kind of sharing results with other people. But I wouldn't try to productionalize that code.
So if I could add one more thing, maybe two points. So
Yeah.
I agree with you. It's a very good tool, but it was meant to build prototypes.
Yes.
So for the audience members, if you haven't watched this, Joel has, I think this is a 2018 video that you can find on YouTube. He basically destroys everything anything that is related to Jupyter Notebooks, and then Jeremy Howard has a response video. And that, like when I watched that response video, that was the first time I came across NBDev. So back then it wasn't really at the maturity level that it is right now. And there are some other alternative tools as well, which would basically allow you to write unit tests, integration tests within your notebook, take pieces of code, put them in a Python script, make it productionized, basically Dockerize your code, from your Jupyter notebook. So there are solutions out there, but the question is that the best practice? Should we follow that suit, or should we become more software engineer mindset of people who are working in a machine learning domain? And it seems like you are a fan of being more or less I don't want to call it a conservative machine learning engineer, but somebody who actually knows what they're doing, as opposed to just running it through some library or some code that will take pieces. So related to that, same question.
Sure. Yeah.
Unit testing and integration testing. Jupyter Notebooks, yes or no?
I would say at the very beginning, if you're getting something off the ground, if you're not too experienced, then yeah, definitely use something that is automated just to get the ball rolling. But I would say eventually you probably want to know what's happening under the hood, especially if you want to be able to control different aspects of the pipeline, as well as being able to debug what the hell's going on, right? So I'd say at the very beginning, it's okay to just get something out for people to use, but eventually over time, you definitely want to dig into the nuts and bolts of how things work, so that you're able to not only be able to debug what's going on, but be able to maintain it long term.
And I'm sure you have sorry, I just want to say, I'm sure you have a lot of good resources on the same topic, so if you could share them with me, I could make sure that we also post it underneath this video and also on our Slack right after this. Sorry, back to you.
Yeah, sure, sounds good.
Yeah, and I guess like related to that, something that you had mentioned, which I think is a really good kind of segue to like our industry related question. So you've straddled in roles like data engineering, machine learning engineering, data scientist, software engineering, basically like everything. Like
I've done a little bit of everything. Yes.
Yeah. So where would you draw the line between data engineer, machine learning engineer, and data scientist? And is this important? Is it important to draw this line? Like, should we be differentiating these roles, and why not? Why or why not?
Yeah, so that's a good question. So I would say maybe 10 or 15 years ago, I would say that there was definitely a line that was drawn, mainly because, well, the nature of the work has changed from that point. So I would say 10 or so years ago, I definitely agree. So 10 or so years ago, we would say that a data engineer is focused on taking data and putting it into some tangible form that, data scientists or machine learning engineers can use. So they would have to be good at, SQL or table creation, or just being able to put something in a tangible form that people can use. And then you've got machine learning engineers that are focused on, really torturing the hell out of your data to give you kind of the best model and performance, right? And then you've got the data scientists who are kind of like, they're more customer facing. They take a look at the data, understand, the trends, and being able to tell stories of the data to either inform stakeholders or people who are interested in just, what to do next in terms of developing the next feature or making key decisions on their next products. So that 10 years ago, that definition is definitely what is predominant, and a lot of people would agree. But because of especially with the pandemic and the proliferation of startups, where you've got a lot of these companies that are starting off the ground, especially them being remote in nature, you're going to have people eventually wear many different hats to be able to get something off the ground. So it's going to be very common for people who are, let's say traditionally trained as, data science, got to be able to get their hands dirty with some, pipeline work or being able to deploy models. So the lines are being heavily blurred because you have, all these different companies, they're trying to start to make something, cool, I guess. So them being able to wear multiple hats at any given time is definitely more common now. So people, people can definitely have, a mastery in terms of, the kind of current role that they want. So let's say they were focused on doing machine learning engineering or data science, that's definitely, advocated, but they're definitely going to have to, get their hands dirty in other aspects of the pipeline or other aspects of, getting the product off the ground to be successful. There's definitely need to go above, and beyond your original calling, because not only does it make you more marketable, but it allows kind of employers to see that you're definitely kind of a key resource to keep long term, right? So it's more attractive to have someone that definitely focuses on data science, but they have kind of their hands in different places and know different parts of the pipeline. It's a much more marketable kind of set of skills to have that'll attract employers and be able to convince them that you're definitely a resource to keep long term. So I think at this current stage, the lines are definitely blurred, and it's good to blur that, because it's definitely good to know kind of more than one kind of calling versus I'm focused on data science, machine learning engineering, and so on.
Yeah, thanks so much for that. I actually
Yeah.
have a follow-up question related to that. So you talked a little bit about how, having broad knowledge and being able to wear many hats is kind of key, especially because, you're getting new tools, things are changing. There are a lot of, new startups, new companies kind of trying to build great things. But where is there a point where you think data scientists or engineers should have a deeper knowledge in an area, and how do they know what area to focus on? Like, do you have any tips for that, or is that mostly just like,
Yeah, so I would say that's definitely depending on kind of the current needs of the company. So it depends on what stage they're at. Let's say you've got a company that has no idea how to kind of release, a model that people can use. So I would say you would want to focus your skills, or you want to focus learning on just the current demands and the current needs of what you need to get the product out the door. So in that case, you probably want to focus on, understanding, data pipelines, and when you're training, a machine learning, kind of model. That's, I would say, a little piece. It's just a small piece of the puzzle. You've got stuff beforehand where you're consuming data, you're doing feature engineering, you're transforming data. You've got the code for training a model and doing inference. But then you also have the post deploy, where you want to maintain the model, take a look at performance metrics, make sure that it's not deviating away from what you're training on. You've got concept drift. You want to be able to incrementally retrain or retune the weights of your model every now and then. So you want to be able to focus on kind of skills or things that suit the current business need, and that's where you should probably steer your learning to. If you decide which one to do next.
So related to this, and it might actually connect very well to our next question for you, Ray, is I can't agree more with you that the lines should be blurred. I really like that concept.
Yeah.
However, there's something that might challenge that, and that is if we look at companies that are a bit more mature, so we're not looking at your regular startup scale up. And the example that I could give you is a couple years ago, you probably had folks who were data scientists who were more client-facing, for lack of a better word, consultants, right?
Sure.
And you didn't necessarily have a lot of consultant data engineers, whereas today, that's a different case. Today, I mean, with the change of recoining and changing of titles and whatnot, so now you have data architects that are basically your good old senior data engineers that could do everything. They know DevOps as well and whatnot. So in terms of talent and what they should know about, do you think that in terms of drawing these lines, is it still a good idea for enterprises, for, let's say, financial institutions, for your consulting companies, and I'm asking this because I come from that world, to have everybody to play every role, basically? Or do you have to go more centralized towards, these are my back office, so to speak, what I usually call dungeon mindset people who don't want to talk to anybody, they just want to focus on the work that they want to do, as opposed to sales-minded people who want to put in front of a client or internal stakeholders and say, this is what we've been done for the past sprint or so.
Yeah, so that's a good question. So I would think that as you kind of mature in your career, it depends on your career trajectory. If you want to eventually move to, let's say, a larger organization or like a larger enterprise, then I think lines are definitely drawn mainly because, well, you have a lot of resources, right? You can dedicate a lot of resources to focus on one or two particular, so that's where the lines make sense. But when it comes to, let's say, startups that consist of, let's say, 5 to 10 people, where you're concerned with getting an MVP or minimal viable product out there for people to use, then you need to leverage everything you can in order to get something out there for people to use. So it depends. So I think if you're looking towards, an enterprise or kind of large corporations such as the Big Five, or something that's very stable, that has kind of an international presence, then they have a lot of resources to be able to allocate specifically, what people should focus on rather than having to wear many hats, because they have the resources to do it, and they have because they've grown so large, they definitely have the experience to be able to, develop, products that are very customer focused. They know exactly what the customer wants, so they know exactly what people should be focusing on and to deliver those products. So I guess it just depends on the walk of life in terms of the company. So if they're very large, then it makes sense to have the lines completely drawn, because you've got the resources to throw people at it, versus a startup where you're trying to get a product out to people. That's when the lines are blurred. You have to wear multiple hats to be able to get something out there.
Cool.
Yeah.
So just one more quick thing, and this is again maybe a good segue into our next question, and that is with respect to education. What are your
Yeah,
thoughts on
sure.
that front? Is this something
Mhm.
that you should pick up? After a couple of years of working at a startup company, scale up company, or do you think that this is something that should be taught in universities or boot camps?
Oh, like in terms of like best software development practices, deploying all that stuff, like that stuff.
Anything. So
Anything?
even when
Okay.
it comes to drawing those lines, the roles that you play, the type of
Yeah.
responsibility that you have, the hats you're wearing,
Yeah,
anything
sure.
that falls within those lines. Yeah.
Yeah, so back 10 or 15 years ago, they really focused on trying the theory and kind of know-how of how exactly we train a model. So that figuring out the kinds of models to use, figuring out kind of what the best model is for a certain application. But usually with very traditional courses, they don't deal with anything outside of that. Usually the data is supplied to you in a very well defined format, very clean. You don't question the lineage or the provenance of the data. And after you train a model, they don't really tell you how to use it after it's done. So the thing is that they're trying to focus on the theory of what model to best use for a certain situation, which is definitely has merit, but that's pretty useless if people aren't able to use your model. So back then it made sense to really focus on the theory behind deciding which model to use. But at this landscape, in terms of the different kinds of jobs that are available, the different kinds of companies that are available, we definitely need to start growing kind of the frontier of what we need to learn. We definitely need to understand where the data comes from, how to process the data correctly, transform it in a way that the model can use. Obviously, with model training, that's definitely important, because you need something for people to use. But I would definitely focus on what happens after your model is trained. Being able to put it in the hands of people that can use it. Being able to monitor your models, being able to understand constant drift. Let's say you've got some data that's coming in that's completely different than what you trained on. What do? Do you simply ignore it? Do you update your model? Like, what are the what are the kinds of things that happen after you deploy your model? So it's those kinds of skills that are actually what is desired, what is most useful to be able to get something tangible in the product, get a tangible product in the hands of people. So I think at this day and age, we definitely need to understand more. And in terms of courses and boot camps, they're definitely understanding that there's definitely more stuff that's available. One workshop that I highly recommend is the Full Stack Deep Learning workshop. It's very recommended because it tells you pretty much the entire life cycle from, let's say you've got a model that you've trained. What do you do after that point? How do you host it? How do you deploy it? How do you monitor the performance? What do you do if you want to update your model? Like, those are the kinds of things that those are the kinds of questions that you need answered to be able to have a successful product that people can use. But yeah, there's other courses on Coursera and Udacity and even Udemy that kind of teach you how to deploy models to production. So I'm liking that I'm seeing more of this proliferation. It's definitely nice, because those are the kinds of skills that you definitely need if you want to be not only successful, but as a marketable kind of engineer, as a candidate in engineering or data science.
Yeah, so I have a quick follow-up question about that actually. So you
Mhm.
talked a bit about, just like how there are different ways to like learn data science, whether that's in like boot camps or like
Yeah,
university,
sure.
and how like, oftentimes despite kind of like democratizing the field, it's not there's some things about those like learning methods, like you get a pretty clean set of data compared to like how you would get it in real life, which is, you have to like, question where the data is from, like make sure you understand the biases inherent in your data. So
Absolutely.
you kind of touched on this a little bit earlier as well, but like where do you see the growth in the industry as a whole, and how will education kind of grow with that? Do you think that you know data science education will shift less from universities to boot camps, or is it more just like on the job training, or how do you kind of see people learning about data science, and like like what are your thoughts on that?
Yeah, that's a good question. So I'd say that the current state of the pandemic has definitely changed the landscape in terms of education, because especially when you're trying to adhere to social kind of distancing principles, where education has to be done remotely, right? So if you can with universities and colleges where they're shifting towards kind of remote kind of nature because of the pandemic, well boot camps and coding schools have, by nature, most of them have already been remote. So in terms of the landscape, I think it's definitely going to change, especially this pandemic has definitely tested our ability to work. And I think now that in terms of the quality of education you get, the types of things that you learn, and especially the people that you interface with, it's the quality is starting to be on par, even comparable with institutions that are traditionally attending and going to a physical place. So I think the landscape is definitely going to change, especially this pandemic has tested a lot of the limits in terms of being able to work as efficiently from home versus in an office. But I personally think that online education will probably take over. It's heavily proliferated, and I think it'll be even more so in the next few years or so.
So, kind of as a last related question to that topic before we move on to the next.
Yeah, sure, absolutely.
Related to accreditations, I guess, like one thing they have in common. So you get like a diploma from a university, whether you get like a master's or undergrad.
Yeah, sure.
More and more like data science master's programs are popping up, and like there are also like boot camps and MOOCs and stuff like that from like
Sure, yeah.
name brands. What are your thoughts on, I guess, like those accreditations? Are they important? And if they are, why is the boot camp accreditation better or worse than a university education?
Yeah.
And if it's not important, how do you think that data science candidates and applicants can show their skill set to potential employers?
Yeah, okay. So usually what I recommend people to do, especially if they don't have experience in the area that they're looking for, is to work for a startup or work for a company that is looking for people who have the aptitude versus the desired education, so to speak. So when I've built machine learning engineering teams and computer vision teams from the ground up. I've interviewed a bunch of people, and I've also been an interview candidate as well. And the overwhelming theme that I've seen is they take a look at whether or not you can actually do the job. I think in terms of education, I think it's just there to pass kind of the HR step. But we take a look at whether or not if we gave you a problem, can you actually give us something that we can work with? Can we work with this person? How well does this person work with the rest of the team? In terms of their social skills, and if we were to put them on some independent problem, can they come up with something that we'd be able to use? So personally, I look for aptitude and as well as just being able to work on a problem and solve it, versus someone that comes from a very prestigious school. So I look to see whether or not they can give me something to work with, versus I know the theory behind everything, but if they don't give me something to work with, then what's the point?
Cool. So and I think we have had long conversations about this for the past probably year and a half. I unfortunately I can't challenge you there because we both belong to the same school of thought. However, I, similar to a few of the previous guests, I would like to also invite you at some time in the future to join a kind of like a dispute group, so to speak.
Sure.
So that
absolutely.
we could talk about this, maybe even randomly, very similar to how people do it in Europe. So you may actually have to go ahead and talk in the camp of people you don't belong to. So that would be a fun conversation to have.
So for sure.
But back to what we were talking about today. So you mentioned productionizing. You mentioned a few other skills, so to speak, that go beyond just modeling for any use case. So building on top of that conversation, and mainly focusing on software development lifecycle concepts, what are some examples that you can give us that you think today, at this day and age, people need to know by heart, that 2-3 years ago it was an optional thing? And the example I usually provide is Docker. Docker is something that probably a couple years ago you wouldn't even see it
Yeah, for
on
sure.
a job description, right? But
Yep.
now
Yep.
everybody wants it because they want to create microservices because they
Yep.
think monolith doesn't work anymore, which is wrong, by the way. Uh, but I want to hear your thoughts about this. So the top maybe whatever number that you can give us in terms of things that originate from software development lifecycle that you think they are a given right now. Everybody needs to have them in order to have a chance, basically.
Yeah, absolutely. So, back, several years ago when you wanted to, just prototype and, create a model that people can use, it was mostly very experimental. Being able to, track experiments was hard unless you wrote it down on like a piece of paper or a notebook or something. So, things that definitely people need to know in order to be organized is, document everything you've done. Either you doing, any functions that you write, either make some simple doc string, or if you're taking a look at experiments, definitely track your experiments, either using, Neptune or weights and biases or something that will be able to help, track your experiments, over time and be organized. So tracking experiments, document your stuff heavily, because you'll never know who will take over the, whatever you're working on, if you get kicked off to another project, or maybe you'll work on something, then you'll go back to something else, and then when you switch back, you don't have the right context. So having documentation is definitely key to be able to keep stuff organized. I would say learn the process of doing a code review, right? So let's say you're developing a feature. Definitely, learn the nuts and bolts of version control, and using GitHub or GitLab or even Subversion if you want to be really, really kind of old school. But version control is definitely key. The practices of doing a good code review, where you'll do a feature, let people take a look at it, review it, and push that to a branch. So code reviewing, documentation, model tracking, and get into the habit of unit testing whenever you can, especially because it will remove any doubt of whether or not something that you've developed is working properly versus not. So definitely unit test often and sooner rather than later, because it kind of minimizes what you debug in the end. And I would say, in terms of the software development lifecycle, even though you're not technically coding, I would say frequent communication is key. Whenever you have an update, or whenever there's try to schedule frequent updates with either stakeholders or people who are working on the same project with you, because you don't want to be able to get to a point where both of you are working on something similar where you've wasted cycles. You need to be able to, if you have to work on something in parallel, it's good to have that communication so you're not doubling the effort. So this kind of stuff was foreign to me, many years ago when I started, working on, kind of machine learning engineering products. So I would say be organized in terms of documentation, unit tests, and model tracking, and just frequently communicate your ideas and your results to people who have a vested interest in the product succeeding.
So kind of related to that, is there sort of any recommended tools or packages that you would say are very important, especially to computer vision? I know you mentioned earlier Docker, and you also mentioned TensorFlow. Like, are there like
Sure.
people who are trying to get into the field? What should they learn? Is there like a to-do list of things to learn?
Yeah. So in terms of let's start from the beginning. So let's say you've got a model trained. Let's start from the beginning, where you have to take a look at understanding the data that you have. So definitely, if you want to be able to you want to be able to do some sort of exploratory data analysis to see if you have the features that are required to be able to be expressive, to come up with a good answer. So definitely some grasp of some sort of data analysis tools will be good. You can use stuff from Seaborn or Matplotlib or whatever. So stuff just do with some exploratory data analysis tools is good. And in terms of post, we mentioned Docker, of course, but there's all of the tools that you can definitely use. Like Airflow is a very popular one. Celery, Luigi is also a very popular one too. So in terms of kind of the recommended frameworks, you want to take a look at pre and post deploy. So any feature engineering tools or any data analysis tools, Matplotlib or Seaborn is good. And then post deploy, TensorFlow Extended, Celery, Docker, or Luigi. One of those things are good too. But yeah, other than that, I think that's all I can think of right now.
I could add a few. Since you mentioned version control,
version control.
I'm a huge fan of version controlling beyond code. So when it comes to model registry, we can talk about it for probably a couple minutes. So DVC is definitely something for data and model version control.
Yes,
I would also add something. So I don't know. I probably have to ask you about how you feel about feature stores, because they're not a new concept, but they're new paradigm. So in my opinion, I mean, if you have a huge team of data scientists that are sitting in different functions, different departments, that's probably something you want to take a look at. There are some tools over there that are not yet 100% mature. So whichever one you learn, it's going to work for you. And since you mentioned weights and biases, I just have to share my personal preference as well. So MLflow is something that a lot of people also use for experimentation tracking and whatnot. These are basically the winners of the market in the past couple of years. The DVCs and weights and biases / MLflows of the world are the ones that a lot of people started using, and then they just had more and more supports from the open source community. So now they become the de facto tools for any of those steps that Ray mentioned. I have a question to change the scenery before I hand it off to Amber to ask you our final question. And
sure, go ahead.
It's more or less a kind of a funny question, but since we talked about version control, what is the longest PR that you've seen that did not get merged? And was it? I mean, it doesn't have to be yours. It could be something that you were reviewing and you just didn't see a way to merge it into the main branch. But can you tell us a story about that?
Yeah, so so there are two stories. One was a PR that I did, and one was a PR that I reviewed for somebody else. So I'll start with mine.
Good.
So it was it was at a startup about 2014, 2015. It was a way of trying to change the way we handled reading in camera images. And it was a way of trying to be able to, understand where the objects were and being able to find kind of the right parameters of the camera so we know where things are situated in space. So the pipeline that I developed was quite involved. It dealt with a lot of, computer vision applications and a lot of, very, 3D geometry and scene understanding. So that PR was about 15,000 lines. And what happened was at the end when I finished, there was a reorganization and layoffs. So my product that I developed was no longer relevant. So that did not end up getting merged because that feature was unfortunately canned. So I spent about 2 months on that before, gone. So
speaking of uncertainty, eh?
yeah, I definitely speak of uncertainty. So that was one story. It was painful, but it was a lesson that I learned where, the things with startup is that they're very volatile, so you have to be careful. So the next story dealt with a couple of companies back where there was a change to try to make the code more optimal, where we, in terms of, the amount of floating operations per second, where there were a lot of matrix vector multiplications that were very suboptimal, where someone tried to change it so that it was vectorized. So what happened was the changes made sense, and it seemed to run fast on one particular, computer on the cluster that we had. But when I tried running it on other computers, there was a significant slowdown. So I dug through the code, and what happened was they made a couple of assumptions that were invalid. So with that, it required a significant re-engineering effort. So that pull request was about 8,000 lines, and I tried to. So what happened was I requested changes saying you need to change these sections because they actually don't make sense for these particular clusters. So what ended up happening was that person abandoned those changes because it was just they could not get to the point where it was efficient. So we had to hand it off to somebody else who eventually did do it. But I did not approve those changes because it worked for one machine, but it didn't work for others in our and others in our cluster. So yeah, that was unfortunately a letdown for that person. But
It's good for people who may end up applying to a company where you work. Now they know what to look for before having a conversation with you.
Yeah, I really dig deep in the pull request, make sure that actually works, and yeah, for sure.
All right, cool. That was funny. Thank you.
Yeah, that's awesome. I appreciate those stories a lot. So especially as somebody who's kind of like just starting out in the field, yeah, very, very good to know.
Oh yeah, like I've sorry, I don't mean to derail, but even with a veteran like me, I make a lot of really silly mistakes. Like I was debugging code for about 2 weeks, and the reason why it wasn't working was because I used the wrong variable.
Yeah.
I've had a lot of wars. I have a lot of war stories, and people that are experienced as me, we can make silly mistakes too. So
it happens to everybody. Yeah. It's not just
it happens to everybody. So yeah. So if you feel like you've made silly mistakes, don't worry. I probably made just as equally embarrassing, or not even more embarrassing mistakes.
Yeah. So kind of like related to that, as like a veteran, like in the field, again, it's been like such an honor, like talking to you guys and like being here and learning from like both of you. If you could say, or if you could give one tip or piece of advice to your younger self when you were just getting into the field, when you were just like, learning about like machine learning engineering, data science, and just like hopping into like the industry, like what would that piece of advice?
I would say I would tell myself, don't worry, there are a lot of online courses and boot camps that will help you. Yeah, because I thought then that university and college education was the de facto standard. So you had to go to class, you had to get everything from the prof. Like I was under the impression that there were no external resources or things that people were doing outside of the university setting to actually help you, and that was a main concern of mine. Where if I start working in the field, I'm, all I have are my textbooks. There's nothing, out there that'll be able to kind of help me, get to where I need to go. But then I would tell myself now that, don't worry about it. It's going to settle itself. There's going to be, a lot of people are working on the same problem, and information is definitely going to be shared across everybody. So I would tell myself not to worry about, trying to understand everything in a very traditional setting. There's lots of online resources, lots of, people such as yourself that will be able to bounce ideas off and, get help, and especially with proliferation of MOOCs, and you definitely want to leverage the online community. Like people are willing to help you even if you've never met them before, and they're on the other side of the planet. So I would say, don't worry, it'll settle itself out.
Yeah, I really appreciate that, and I honestly really empathize with that advice as like somebody who came from like a humanities background and who was able to like connect with you guys. I've like never met either of you in person, but I feel like
definitely, yeah.
The upper half of you. I don't know how like the rest of you looks like. But yeah, so I guess like Armand, do you have any last questions before we close off?
I do, yes. So the last question I wanted to ask you is a bit different from what we've talked about. So it doesn't not that it's not related, but it doesn't have to be, more or less deep into software development or machine learning engineering, but it's looking at this from a product lens. And specifically, obviously, a data product lens. So I'm sure you've been part of building a lot of data products. Is there anything in terms of examples, best practices, funny stories, because it seems like they work very well in this call, anything that you want to share with us for when somebody wants to start the development of a data product? And again, this is not something that relates to code necessarily. It can be very broad. It can be related to anything such as user interviews or whatnot, but anything that you want to share in that front that would make sense to people who have probably never dealt with data product building, that would be appreciated.
Yeah, so I think the number one thing that is important is scoping. You have to decide whether the product that you're building, not only is it feasible, but it makes sense and there's a market. Because I've been on a lot of teams where they're trying to build something and it's really, really, really cool, but then the business side is like, well, how is this useful? Well, how are we going to get this into the hands of our customers? So I've been in a lot of situations where there's been a lot of engineering work dedicated to building something, and it ends up getting shelved because no one actually wants to use it. So the communication between the business side as well as the engineering or data science side is key. So I would say there has to be collaboration between the business side as well as the engineering side, where you should come up with problems that solve business requirements versus what is actually cool. Like things like let's take a look at your company, and why don't you list the top 3 things that you wish were working better. You want to focus on what to achieve. Do you want to increase conversion? Do you want to reduce inventory? Do you want to increase margin or profit per item? Like, what you want to do is focus on what is good for the business, and then from there build AI solutions that solve that particular problem. Brainstorm potential models or solutions that make sense on solving these. So now you're figuring out how you want to achieve solving it. If you want to be able to assess how feasible these potential solutions are, is the project even feasible? Do you have data or features that have enough predictive power to give you a signal as to whether or not it makes sense? You want to be able to also design metrics that make sense in agreement between the business side of things and the engineering side of things, because I've seen teams where they'll take a look at a training a model and be like, oh, the loss function is 0.005 or something, or the accuracy is like 99%, but it doesn't meet the business objectives. Where, okay, well, sure, it's 99% accurate, but what does that actually mean to us? Does that mean that the customer will be able to use the product successfully? What does that actually mean? So I would say scoping, figuring out whether there's an actual need for the product you're developing is number 1, and number 2, being able to come up with some metrics or understanding between the business side of things as well as the engineering side of things to make sure that you're in agreement of what you're actually developing. Also consider, actually, one thing that I is not mentioned frequently is you also want to consider the ethical ramifications, right? Well, will this product create kind of a net positive societal value? Is it free from bias? Is it, are there any other ethical concerns that you have to decide before you develop this product? And then once you have that, then you want to make some sort of prototype or some POC to make sure that it actually makes sense before you proceed. And then once you have this thing in place, then you can determine milestones and budget for or the resources that you need to actually develop this feature. So I would say figure out the business need, align this with use cases on the business side and the engineering side, and then develop kind of a proof of concept to make sure that it actually is what you're looking for, and then you start allocating milestones and budget to that. And then the last thing that I'll definitely push on is don't choose the model that is the best performing, let's say at in terms of the latest research paper in NeurIPS or whatever conference that is definitely beating the rest of the models, the photostatic data set. You want to choose the model that makes the most sense depending on what data you have. I've seen products that just use a simple logistic regression classifier and it works. So you want to be able to choose a model that makes sense in terms of the data as well as what is available versus the best performing one. So you're trying to develop a product that people will use, not necessarily the best performing.
If I could share a small story, I know we're almost at the mark of the hour.
That's fine.
As somebody who sells AI solutions, I usually hear this in response to what I say. People usually tell me, "Are you nuts? You are selling something and you're telling us we don't need that." And that's the truth. I mean, you don't necessarily always need even a logistic regression. Sometimes the good old expert system solution, which is basically a bunch of if then else heuristic rules, outperforms pretty much everything that you have in terms of the best performers in the market. So don't get fooled by all of these the numbers that you see in the papers that are probably not reusable or retrainable, or you don't have access to that large amount of data. So yeah, sometimes I go into meetings and everybody gets excited about AI solutions, and the first question I ask is why? Are you selling this, or are you going to work on this because it's sexy? Are you doing this for the sake of AI, or you actually have a problem that your rule-based systems can't solve? And that's when we start having conversations about AI solutions. Anyway, so I'll 100%. Pass it on to you, Amber, to take care of the closing remarks. And I just wanted to thank Ray on my own behalf. This was very
Sure.
helpful, and it was really nice to finally have a conversation
you as
with you.
well.
Yeah, sure, absolutely. So again, like just wanted to echo what Armand said. We really appreciated the conversation, Ray. I mean, I know I learned a lot, and I'm sure our audience also learned a lot. You can definitely reach out to Ray on LinkedIn. He is on LinkedIn, and we will make sure to include his social on the description below as well. And
Sure.
yeah, definitely tune in every week. So we are going to be back again next week and the week after. And if you have comments or feedback, or you want to, potentially share your work on our podcast, definitely let us know either via YouTube or on our Slack channel. And please don't forget to like and subscribe. So thanks for coming and see you next week.
Take care. Thanks a lot.
Thanks, everybody. Bye.
Thank
Bye.
you.